Happy?
Yes, I think so.
Okay, then I will mute myself and press record. So whenever I'll tell you when we're recording.
Okay.
Oh, Andrew pressed record. So it's been recording for 21 minutes. off we go.
Can we edit this?
Yes, of course we can. So Andrew, edit from a minute.
Okay. Hi everyone. So this week we're going to be looking at routing. My name's Elaine Haig and I'm a senior lecturer in cybersecurity at Cardiff University. And we're also going to be joined by Rebecca.
Hi there, everybody.
Do you want to introduce yourself and say who you
Hi,
are?
I'm Rebecca Harrop. I'm a senior lecturer in cybersecurity at the University of Bedfordshire and also do some networking for the Open University. And it's my pleasure to join you this evening.
Fab. And we've also got Elizabeth. Elizabeth, I don't know if you want to say hi.
Hi everyone, good to see you again. My name is Elizabeth and I'm leading the Cisco Networking Academy program in the UK and Ireland. And yeah, excited to learn more about all things routing tonight.
Okay, so Rebecca, if you want to start to talk us through the slides.
Sure, no problems. So basically, when you're routing, you're moving from, if you think of a router as connecting a LAN to a LAN, so we've heard that a local area network is a network that's usually in one area only. So that might be, I don't know, it might be your college or your place of business or even your small office, home office. And then when we want to connect and go out, typically across the internet, and connect LANs to other LANs. So maybe you have another college or another university, or you have another business that you want to communicate with that's distant from you. Then what we need to do is go through a router in order to be able to find the way from source to destination. And in a way, a router sort of acts like the signposts in between all of the places that you might be going. So if you think about this here, that we're going from, I think we're going from, where are we going from? We're going from somewhere in work nearby Milton Keynes. I think that's where where our pinpoint is, up to John O'Groats. Then maybe every time you're going through a router, the router's sort of saying, you're saying to the router, where's John O'Groats? And it's saying, I don't know, but I think it might be in this direction, and it points you north. And then maybe it jumps to the next router or to the next hop, and it says, which way is John O'Groats? And it says, I don't know, but I think it might be this way, and it points you a little bit further north again. And then maybe you get to a router in Birmingham, and then that router in Birmingham says, you say to it, where's John O'Groats? And it says, I don't know, but I think you go this way, and we jump up to Cardiff. And then perhaps along the way, they keep signposting, or they keep jumping you closer and closer and closer to your destination. Now, routers can do this in two parts, by either having a default route, or they have a route to a network that's either learnt statically or that's learned dynamically by using routing protocols. And they learn about where other places and other networks are. And that's the way that they effectively bounce a packet that's trying to get from one source to another destination from hop to hop, forever getting closer. So it's a little bit like your sat nav telling you turn left, turn right, go north, go south, until eventually you get to your destination by taking each turn in turn.
Yeah, and I think another thing that's interesting on this example, Rebecca, is that it's actually showing two routes, but it's saying the best route because it's a little bit quicker.
Absolutely. So when we learn about routing protocols and we learn about how networking protocols work, we sometimes call them best effort delivery. So they don't necessarily have to just go one way. They can go multiple routes to get to the same place. And that's indeed how they work. And sometimes they use metrics. So like you might use one metric that says the shortest route, where actually the shortest route isn't always necessarily the fastest route. And it's the same as a sat nav in that sense. So in fact, that's exactly the case that's happening in our picture here. The one that's slightly longer is also a heck of a lot longer in time as well as distance. So sometimes you might choose to go a shorter route in order to take or a longer route in order to take less time if there was a traffic jam, for example. So exactly as we're saying, there's time and there's distance, and there might be congestion along the way. So sometimes we have to take multiple things into account. And that's sometimes what our metrics in our dynamic routing protocols can do.
Yes, because I guess a network is exactly the same as a road in that certain times of day, those roads might be very busy and there might be congestion, or there might be a fault like some roadworks or something. And in that case, then that road, which normally might be the quickest road, on that particular occasion might be a lot slower. And so routers are able to deal with that in the same way using networks, aren't they, Rebecca?
That's exactly right. And indeed, I mean, from a networking perspective, there's lots of things that impact on network performance. So you've cottoned onto a few of them. It's exactly like our roads. It can sometimes be the number of users, whether or not there's any bottlenecks, and the actual speed, if you like, or the bandwidth of the available connections between 2 points, which I suppose is equivalent to how many lanes of the motorway are open. And if you start shutting down some lanes, then obviously the bandwidth decreases. So there's multiple things to be taken into account. And what a router can do is also, if a road gets closed, or if a network or a route to a distant network suddenly goes down, or is it becomes unavailable, it can reroute and find an alternative pathway. When we're talking about routing, a lot of the time we are talking about IP addresses as well. So our IP addresses never change as our packets are routed through networks from source to destination. The IP from source to destination stays the same. In order for it to, it's always like me saying I'm always going from work to John O'Groats. That information stays the same, whereas sometimes our MAC addresses actually change from hop to hop. And yes, so exactly as it is on the slide right now, what we're discussing, the time is equivalent to like the speed of the connection and how fast that connection is, and whether or not it's a very, very fast connection between them or not. And then distance would be how many routers we're going through on the way. And sometimes exactly whether or not how many people and how busy that line is could be equivalent to our congestion. I'll let you explain that one, Elaine, if you've got.
Yeah, sure. So we've done a little demo of this in a previous session. I believe the video should be there. So what we can do, similarly like a sat nav, you can kind of see the different roads that you need to go on, the different junctions, where you need to go on and off a motorway, for example. You can kind of see that laid out on a sat nav. You can see the direction and the journey that you're going to take. We can actually see the direction that our data takes through the internet as well, because we can use a little utility, a little command called traceroute, and that will show us the actual hops. So it'll show you the network devices, the routers that particular packet of data goes through to get from the source to the destination device. So this is an example of an online traceroute utility that you can use. So you can just go onto that website, and there are a number of them. You can just go onto that and type in any kind of destination website that you want to use, or if you can think of an IP address, I tend to use 8.8.8.8 because that's the Google DNS server that I know is physically based in America. And it will show you then the different steps, the different hops that it goes through. So this might be a little bit small, but you can figure out some of these IP addresses. These are actually the IP address that is given to that router. And because it's got the IP address, sometimes you can pick up a little bit more information about what that router and what that connection is on each hop. So remember, the data has to get from one physical place in the world to another physical place in the world. Data is always made up of something physical. So if you're connecting to a server, if you're connecting to a website, the information, the data that makes up that web page is physically stored on a server somewhere in the world. you don't need to know where in the world it is. But if you use traceroute, you can figure out where it is, because it shows you the different hops that you need to take for your request to get from your PC, the source, to that server, which is the destination. And then obviously, if you're downloading a web page, then that information is going to come back to your PC at the same time. So that can be quite interesting, and it can be quite it's interesting to see how many steps the data has to take to get from one point to another point. Sometimes you can do a little bit more digging if you're interested and figure out roughly where in the world the devices are, because sometimes it can figure out based on the IP address roughly whereabouts the device is. So I'm not going to run it right now, but we're going to show you a simulation of traceroute a little bit later on. So what I'm going to do now is I'm going to show you this little network using Packet Tracer. It's one that I didn't make earlier, but Andrew and Bryony did. And this just shows a very simple little network. It's got 3 PCs and it's got 3 routers. So you probably wouldn't have a network with just 3 devices and 3 routers, but we're just going to show you for the purposes of figuring out how the routers work. So one thing that you should be aware of, which was probably covered previously, is there's another term that we use for a router when you're using it on your network, and that term is the default gateway. The reason that we call it a default gateway is because if you're on a device, a PC, or even other devices, your phone or something like that, the data that you send can travel quite nicely around its own network. So for example, if you're on a device at home, you're going to have your router that will you can use to get in and out of the network. Now all the devices in your home can speak to each other because they're all on the same network. They're probably going to be connected wirelessly because most home routers are wireless as well. But if you want to get outside of your house, what you're doing is you're actually going on to a different network. So all the devices at home are on the same network, but anything that's not in your house, that's outside of your house, so websites or anything like that, that is a different network. It's the series of LANs that Rebecca was talking about earlier. So that's why we call a router a default gateway, because the gateway means it allows data to pass from one network to another network. It's like opening a little gateway at a door or something like that. And we call it the default gateway because you'll tend to all be connected, on any one network, you'll all be connected to one router. So routers are really clever because they can belong to more than one network at any one time. So this router, for example, it's got 3 connections. It's connected to this network, which has just got one PC on it. It's also connected to another network, which has another router on it. And it's connected to a third network, which has another router on it. And you can see these connection IP addresses. These are the network addresses for each of these 3 different networks, and they're all very different IP addresses. So that's the brilliant thing about routers, is they can belong to different networks at the same time, and that's how they allow data to pass from one network to another. So the first thing I'm going to do is we're going to show you how this router is set up to be able to send data from one network to another. So I can actually open up the details of the router. And here you can see the 3 interfaces. So the interfaces are basically the network cards. So for every network, you're going to have a network card. If you've got a PC, you'll probably have maybe 2 network cards. You might have wireless on there. If you've got a laptop, you're most likely going to have 2 network cards. So one network card for your wireless network and another network card that you can plug a LAN cable into for a wired network. This router has 3 different interfaces, so it can have 3 networks. If we click on one of them, we can see it's got an IP address and a subnet mask. So this is the IP address, the IPv4 address for that interface. So that's this network. And as I've said, this router is a default gateway for this PC. So that means that the PC also has to be configured with that IP address as the default gateway. If you don't do that, then the PC might be able to send data to other things that were on the same network in this area. There wasn't anything in this example, but it wouldn't be able to speak to any of these PCs that are on different networks, because without knowing that this is the router it has to send the data to first, if it didn't know that, if it didn't have that IP address as the default gateway, it wouldn't know where to send the data. So you have to have a default gateway on any device for it to be able to speak to different networks. So the other thing that we can do is show the IP route. I think I've already done this, maybe. No. I did that earlier, genuinely, and it worked fine.
Just type a do in front of it because you're perfect. So this is going to show us the routing table.
Yes.
Of that router.
It's showing all of it, I think, isn't it? There we go. So this shows what these little codes and thing means now as well. So this is the routing table, and this shows all the possible connections that it's learned. Like Rebecca was talking about earlier, it will learn different routes and different ways of sending data. They've got these little characters in front of them, and that shows some different qualities about that route as well. So for example, C means connected, and you can see that that means it's directly connected to that route. So 66.0.0.0 is one network, and you can see that it's actually connected to that network there. Rebecca, did you want to explain anything else about the routing table?
In a moment, I'll show you a slightly more complicated one, and we can have a look at my slightly more complicated one where we put the internet into play. So at the moment, it's kind of, if you have a look, can you see how now, currently we're sitting on Lamar, I think. So we're on the router on the right-hand side. So the thing that's important is a packet can only be routed to a distant network if that router knows about the distant network, or if there's a gateway of last resort. So at the moment, we can see from that routing table that Lamar knows about the 33 network, it knows about the 66 network, and it knows about the 99 network, which is all of the ones that are in the middle going around in a little triangle. And if you press the space bar for me, please, Elaine, then it also knows about some of the lands on the other side. So it knows about 172.16, which is where Mary is. It also knows about, it does know about the 10, it's at the top of the list. So it also knows where Ada is, and it knows about itself, of course. So it knows about 192.168.0.0. So what that means is that if we were to try and ping from, or even indeed trace route from Hedy to Ada or Marie, then it should be successful. At the moment, though, and we'll come back to this when we have a look at a more complicated, there's no gateway of last resort. So if we tried to go anywhere else, we wouldn't be able to necessarily get there. But let's, so you can only know about the networks that it knows about. So let's try one of those trace routes. Or
so if I open up Hedy, clicked on the wrong thing there. And we're going to run traceroute from Hedy to Ada. So if I go into the command prompt here, Yeah, I probably should have reset this, but
Here's one you prepared earlier.
it is. But I can still show you that. So just to show you what I did, I tried traceroute Ada, and that didn't actually pick it up because it doesn't know what Ada is. Okay, it doesn't know what it is. So we need to know what the IP address for Ada is. There are ways that it could figure out what the IP address for Ada is, but it's not set up in this at the moment. So if we look at Ada, and we'll just open that up. Now what we can do here is we just look at the interface. So again, it's got Bluetooth, which we're not interested in, but it's also got one interface card here. And the IP address that's associated with that is 10.0.0.10. Okay, so that's where you would find that out. And you can do that with, if you've got a PC or something at home, you can like literally just look up what the IP address and subnet mask are. So I don't need that anymore. So that means now that I can ping or traceroute Ada using the IP address. There you are, and that's worked really quickly because it knows the route to go to, and it's telling me here what devices the data is going through to be able to get from one device to another. So we started at Heady here, and then we've used this network, 192.168.0.0. So because it's set 192.168.0.0, that's the network address. So all the devices belong to that network. It's not the address of a device. So the first device that it goes to is 192.168.0.1. And if you remember, that is one of the interfaces that's on Lamar. So you can see here, it's on Gigabit Ethernet 0/0. That's the interface, the network card that Heady is connected to. So it's gone there first. That's the first hop from there to that interface. The next step it's taken, the next hop, is using the 99 network. So it's actually gone from Lamar up to Lovelace as the next step. And then the third hop is to use the 10.0.0.0 network to get to the PC. So the last step there goes to that device. So we can assume that on Lovelace, the connection, the interface that's on the 99 network has the IP address of 99.0.0.1. So it's gone from here to 192.168.0.1, which is the default gateway on this router. Then up to 99.0.0.1, and then over to 10.0.0.10, which is PC Ada. So that shows that. And you can see that that is the quickest way to go. It could get there a different way. It could go from here to Lamar, then to Curie, then up to Lovelace, and then to Ada. So if something happens to this connection, it could still get to its destination, which is a good way to build a network. You've got redundancy. But this is the most straightforward route. Heady to Lamar to Lovelace to Ada. So what the instructions are suggesting we do, and you can play around with configurations like this on Packet Tracer if you have access to it. We can actually remove this cable, so there's no direct connection. We'll destroy the direct connection from Lamar to Lovelace, and we can test that, and we can see if the data could still get there. So if I just, no, I don't want to delete that, sorry. There we are, we delete that. And let's try the same thing again and see what it does. So now you can see it's still got to Ada, but it has taken a different route. So it's started off with the same first hop. It's gone to the default gateway. That's really the only place that data from Hedy can get to, is the default gateway. Then because the 99 network is no longer there, it has to go to the 66 network. That's the only other thing that's now connected to Lamar. So it's the only option Lamar has got. So now it's gone to Curie, which is on 66.0.0.1. So at this point, Curie has to make a decision. So Rebecca talked about routers making a decision as to the next best place to go to. So here, Curie is connected to three different things. It's connected to Lamar. Well, it's not going to send the data back to Lamar because that's where it came from. It's not going to send it to Marie down here because that's an end device, that's a destination device, but it's not the right IP address. So it's not going to send it onto that network. So its only option really is to send it now to Lovelace on the 33 network. So that looks as though this cable is plugged into the interface with an IP address of 33.0.0.2. And at that point then, Lovelace knows that it can connect to Ada, so the data's gone that way. So it's a little bit longer, but it still gets there. It's gone that way instead. So that's just a little demonstration of how devices use routers to transfer data from one network to a different network, and how the routers kind of make little decisions as to what's the next best hop to get it closer to the destination. Oops. Rebecca, I don't know if you've got anything else to add to that, or if you want to show a different example.
That was really helpful. Thank you very much indeed, Elaine. It was really, really good. Yeah, I can show you something a little. Let's just go a little bit further. I think, to be honest, we've done almost everything I'd have probably wanted to say, but let's take it up a notch and show you something a little bit more complicated. So if I show you, if I take control, and if I show you this network, and I would appreciate it if somebody would tell me if you can see it.
That's fine, Rebecca, I can see that.
Magic. So now what we have is a similar kind of network. We've got three networks again, but this time we've got, you can see my mouse pointer, yes?
Yes.
Magic. So up here we have something that's simulating and pretending to be the internet for us. So the same principles apply. Let's have a quick look. I'm gonna go, let's go from PC3 down here, and I'll show you bits and pieces. So this PC, it's all written on the piece of paper from you, is on 192.168.1.3. So there's a 192.168.1. something network here. There's another LAN a long way away, which is on the 172.16.2. something LAN. And down here, there's a 172.16.1. something LAN, and they're connected with WAN links in between. So remember what I said, routers are connecting in LANs together. So if I look on this router here, and this has been pre-prepared earlier, I will need to, oh, I don't need to log back into it. I'm going to do the show IP routes command that we used earlier to show you. So now it's got a bit more complicated. If you have a look,
Rebecca, I can't see the command line if you're
okay. So
I hope you could see mine.
Yes, we could.
That's what I said.
So let me try and see. If I stop sharing for a second and let me try and share my whole entire screen.
Yeah, I shared screen and not
Thank you for letting me know. How about now?
yes, that's perfect.
That's better then, isn't it? Okay, so what we can see here is similar to before. This router has learned about the other networks. Now, we don't need to go into too much detail at all, but it's done that using something that's called a dynamic routing protocol called OSPF. Don't worry about the details, but can you see how this router knows about the 172.16.1? It knows about 172.16.2, and it knows about 172.16.3, which is this one here. So it knows about some of the distant networks. It also has a gateway of last resort. And it says, if I don't know which network, if you give me an address that isn't in my routing table, so if I gave it an address 200.200.200, I've made that up, doesn't matter what the address is, that's not one of my networks that is in my networking table, then I will go that way to try to reach it. So in this case, it's going to go up this way to try to get to somewhere it doesn't know. And that's a sensible way to go, because that probably leads to the internet. And it would probably be a host that was somewhere on the internet if it was not one of these addresses that we're referring to. So let's have a look how that works in practice. What that means in practice is that the same thing as before, if I come on PC3, it should be able to connect to that distant PC2 over there. Let's have a quick look before we go. Same as before, it has its own IP address, and the default gateway is 1.1, which is that interface there on the router. So that we can show you it pinging that first. If I do the command ipconfig, and you can do this on your own home machines, by the way, ipconfig will show you, if you go to command prompt and do an ipconfig, it will tell you the IP address and the default gateway of your own machine. So this would be your home router's address. So I can ping that. What I should be able to do, that's going from here to here and back again. And then I can ping the distant address, which was 172.16.2.2, and I should get a reply back. And it's doing that because the router that it's going to knows which way to go. So again, like we did earlier, I could change that to a trace route and it will show me which direction it chose to go in, because there were several options. It could have gone I would imagine it will go the short way round. And it has. It's chosen to go that way. And what I could do is pull that cable out and it'll go the other way, exactly like we did in the other picture. What I might show you instead, if I do a ping here to 172.16.1.2, then I can get over there. So then that's this PC connecting to this PC here. And what's different now in this network is I've now got the concept of the internet. So I can ping, and this is just set up that the internet's on, there's a web server or something up there that's on 64.154.5. This is a PC now being able to get a reply from the internet and back. Now this time that wasn't in the routing table. So this time it's going through a default gateway. And I will explain what happens if I remove that in just a minute. If I look on router number 2 here, router number 2 also has its own routing table. And if you look at this one, he knows about the other networks. So this router number 2, he knows about his own networks, his directly connected networks. So he knows about the 192.168.10.8 network, this one here. And he also knows about 172.16.3, because he's directly connected to that one. These are what the C's in the routing table means, directly connected. And he knows about 172.16.2, because that's directly connected as well. And then the ones with the little O's are the distant ones, the ones that are far away. So he knows about the 172.16.1 via an O. There it is. And the one that over there. Now this poor little network down here is currently sitting here not doing anything. So at the moment, if I tried from one of these computers, and I'll just to show you that I can ping in the opposite direction. If I just come to this one. So I've already, here's one I prepared earlier as well. That ping to, so that's me pinging from PC2 in the picture to PC3, which works. If I try to ping this laptop that's down here, it's disconnected, right? Sorry, it would help if I pinged it. So that's not going to work at the moment because there's nowhere for it to be connected. So what I wanted to show you was, if I try to plug a cable in, I wonder if I can be fast enough to try and plug it in whilst it's going on. Probably not, but at the moment it's timing out. what I can do is what you'll watch, if I do the ping again, I can press fast forward and speed it up, but I'm waiting for that little light to go green. What's happening at the moment is these routers still don't know about that network yet, but soon they will learn. So at the moment, it still doesn't have a 192.168.11 network in the routing table. See how my light's gone green suddenly? So what will soon happen is that 11 will be added to the table. Not yet. They'll update. There you go. Now it's come up. Can you see how it's saying I found it and I have a new neighbor? So actually I can do this command, American spelling. It tells me that it's now learned that it's got a new neighbor as well. Actually, it's not found it yet, but it will soon. There it is. And now it's found the number 11 network. So what will happen is now that it's in the table and it's learned about this new route to a new network that's suddenly appeared down here, then it can now ping that computer that's appeared down there. And again, that's how a router then connects LANs together. So we made this connection between this router to add it to the larger network that was going on already, and now it can communicate across the networks. So I could come on this laptop, and in theory, I should be able to ping all the way through to the internet now, and indeed I can. Now, one last thing. What happens if my default gateway is wrong, or if I can't get anywhere? So at the moment, I can ping, I should be able to ping to 192.163.1.3, which is be pinging from this laptop, she says, and it won't. There you go, there it does. It's pinging from this laptop to this PC. If I was to mess around and make the default gateways, if I was to mess around with the default gateways, that might actually start to play around. What I'm going to do is I'm going to actually change the default gateway up here on R2. So see here how this has a gateway of last resort that goes off to the internet. Don't worry about what I'm about to do to get rid of it. I'm going to remove it. Assuming it's configured this way. Oh, sorry. Okay. Now, if you don't worry about what I'm showing you the configuration of the router. But if I show you what we showed you before, if I show you the routing table of the router, now suddenly the gateway of last resort is not set. So now I've lost that route, that router was pointing to the internet for all of the whole network. So it may well now fail. So where we were now pinging the internet before, in fact, it might be more interesting to do a trace route and to show you at which point it fails, if it fails. And can you see how it's sticking at its own router? It's only getting this far, and then now this router doesn't really know which direction to go in, because this router now doesn't have its default route anymore. And so sometimes what they have is a way of pointing, saying, if you don't know where the network is, then go this way, go this way, go this way, go this way. And when that breaks, they can't actually get to the destination. I shall fix it. Let me go and fix it, and then it'll come back. I need to work out which interface to fix it to. You see that I'm reading off the routing table that 64, the internet was on gigabit Ethernet 01. So I'm sort of pointing out to it which way to go. That will take some time to fix. And then hopefully I might be able to do that again. There you go. And it's off again and it's there. If I had a different PC, and I don't know how much time I've got, but if I had another PC, what I wanted to show you one last thing. Oh, I'm not allowed to do it in this activity. So I don't think, if the default gateway was ever wrong on a computer, which is what Elaine was explaining from the start, if I had a mistake here, say I'd accidentally put 11.3, it would point it back the other router, then a computer can get it wrong too. Let me put 11.1, which will point it back at the other router, which could cause all sorts of havoc. Let's see what happens. I think, but I have not tested this, so we'll see. But if I now try to ping 168.11.6, which is that laptop at the bottom, it works, which is what I expected. I now try to ping 64.100.54.5. It still works. I suspect that's because it's on. It's still going, it's still getting there. If sometimes if the default gateway is incorrectly configured, what on the host, what typically happens is they would be able to ping between LANs. So these aren't strictly speaking on the same LAN, which is why it's getting confusing. So they'd be able to ping from one another on the same LAN, but wouldn't necessarily be able to get further and go off to the internet. So there we go. And as we did before, at the moment, when it's pinging, so same as we did before, when it's pinging to get to the internet at the moment, it's going that way. So which way is it going? It's going this way, then it's going up, and then it's going across, as you would expect it to. If I do something mean, like pull out a cable, which I'm not allowed to. Apologies, but we have already demonstrated this. What the routers would do is the routers would then, actually I can do it a different way. I can do it this way. What I can do is I can go on router number 3 and I can be really mean. And I can do this. I can close down that interface. I can say, I can go on. Shut it down this way. And then can you see how this connection has gone red? So what I'm expecting now is that what it should do is reroute to find a different way to the internet. And indeed it has. So it's gone the long way round again. And that's what routers do. They find the best path to their destination, and they're able to dynamically change and adjust that route as necessary.
So that's a little bit like in our, motorway scenario, that if a road is closed, your sat nav will send you on a different alternative route, and you can still get there, hopefully.
Exactly that. Exactly that. Right. I think if there was no other further bits and pieces to demo, that we're pretty much there. So
that was quite interesting, I think.
I'll jump back to you, Elaine. And would we got to the end of the slides?
I think we did. There was a final one that just says what we've said, basically, that routers make a very simple algorithmic decision-making process. They can adapt, especially when there's too much traffic or a lost connection, which we've shown, and that we can send network traffic via many simultaneous routes. And I think that's the case sometimes, even if you're sending like a large file, when that file is broken down into different packets of data, some of those packets might actually get to the destination using different journeys.
Sure. And I suppose the only thing I would say is that the only thing we've not touched upon is that, of course, because the router is the gateway, and it holds so much power, if you like, that to a certain extent from a cyber
Oh, you went quiet then, Rebecca.
Yeah, I've lost Rebecca as well there.
No.
I'll pop a message in chat.
important to make sure that no one could remotely access those routers and turn off the interfaces or change the default gateway like I did, because that obviously has very serious impacts for the rest of the network, that you suddenly wouldn't be able to get to the internet or wouldn't be able to reach different parts of your organization.
Yeah, we lost you for a minute then, Rebecca, but I think I got the gist of what you were saying about how important routers are.
Yeah, and just from a cybersecurity perspective, that you need to ensure decent router security. So making sure that they have, physical access is restricted, and that you can't come and let anybody in to pull the plug and pull the power out, and that they have passwords and decent security, so no one can try to remote log onto them and do some of the things we've done today.
Yes. And sometimes lately people will actually hide the router IP as well, so you can't even ping it or do trace route on it anymore. This spoiling all the fun for
Yeah,
cybersecurity reasons.
because of course routers are also quite often targets of denial of service attacks as well.
Yes.
So excellent. So hopefully that's been informative, and you've got a better idea now of how routers work and what the routing process is and why it's so important.
Okay.
Well,
Yeah, well, thank you very much, everyone, and we'll be back again soon. Thank you, Rebecca. Have you got any closing words?
no, not at all. I think we've covered a great deal. Thank you very much indeed, and best of luck with your studying. Happy studying, folks, and we'll see you next time.
Thanks. Bye.
Bye.